Our objectives in this lesson are the following. Utilize the use of table of standard normal distribution. Compute probabilities and percentiles related to a given z-score or normal random variable x. And sketch the graph of the normal distribution. Let's have a quick review of our previous lesson. Joy and Ligaya took an entrance examination in their dream school. Scores are normally distributed with a mean of 120 and a standard deviation of 10. If Joy's z-score is negative 0.5 and Ligaya's z-score is 1.5, what were their scores in the examination? Let us start with Joy. Let us identify the given. Our mean is 120. Our standard deviation is 10. And Joy's z-score is negative 0.5. Let us recall the formula. Let us substitute our values here. Negative 0.5 times 10 is negative 5. 120 minus 5 is 115. Now, let us have Ligaya. Again, the mean is 120. The standard deviation is 10. Ligaya's z-score is 1.5. Let us substitute this to our formula. 1.5 times 10 is 15. 120 plus 15 is 135. Here are the steps that we are going to follow in today's lesson. I will discuss each step as I go along with the example. Example 1. A certain light bulb company manufactures LED lights that has an average lifespan of 50,000 hours with a standard deviation of 2,500 hours. What percent of light bulb lasts at least 55,000 hours? Let us recall the steps. So first one, we have to identify the given. So our average or mu is 50,000. Our standard deviation, sigma, is 2,500. And the random variable here is 55,000. So x is equal to 55,000. Step 2, solve for the value of z. So z is equal to x minus mu all over sigma. Let us substitute our values here. Our x is 55,000 minus our mu is 50,000 all over our sigma 2,500. 55,000 minus 50,000 is 5,000. Divided by 2,500, z is equal to 2. Step 3, let us sketch the normal curve. Locate the z value, 1, 2, and label it. Step 4, analyze the area under consideration. It says here at least 55,000. So the z value of 2 here is the least value possible. If this is the least, then we are going to shade region to the right of it. Step 4, locate the z value in our z table. Let's have the part of our z table. Here is 2.0. Since this is a whole number, it is understood that the hundredths digit of this is 0. Let us get the intersection, and the area is 0.4772. Remember, this area is from the mean to a particular z value. So the 0.4772 is from 0 to 2. But we are not after this area. We are after this area. We know that half of a bell curve is 0.5. Next step, letter C. Let us compute what is asked. We are asked to solve for the percentage of this region, and to solve that, we simply have to subtract 0.4772 from 0.5. And this will give us 0.0228. So this is the area of this shaded region here. And since we are asked for the percentage, we simply have to move the decimal point 2 places going to the right. This will be 2.28%. Last step, let us interpret. 2.28% of LED lights last at least 55,000 hours. Next one, assuming the normal heart rate in normal healthy individuals is normally distributed with a mean of 70 and a standard deviation of 10 beats per minute. Find the percentage of individuals whose heartbeat is below 40 beats per minute or above 100 beats per minute. Again, our steps. Step 1, let us identify the given. Our mean is 70. Our standard deviation is 10. We have two values of x's here. The first one is 40, so x sub 1 is equal to 40. And x sub 2 is equal to 100. Next step, let us solve for the corresponding z value. Let us start with x sub 1. Let us substitute 40 in here, minus 70 all over 10. This will be our z sub 1. 40 minus 70 is negative 30. Divided by 10 is negative 3. Next, let's have our x sub 2. So z sub 2 is equal to 100 minus 70 all over 10. 100 minus 70 is 30. Divided by 10 is positive 3. Next step, let us sketch the normal curve. Let us locate negative 3, negative 1, negative 2, negative 3. And we have here positive 3. 1, 2, 3, positive 3. Now let us analyze which area are we going to consider. It says here below 40 BPM. This is negative 3 that corresponds to 40 BPM. If it is below, then we are going to shade the left side. Now for 100, above 100. This is the z value that corresponds to 100. And since it is above, we are going to shade the right side. Now, we are going to determine the area of this. But our z table gives the area from the mean to particular z value. So let us locate negative 3. We do not have negative in our z table. So let's have 3.0. The hundredths digit of this is 0. Get the intersection. And the area is 0.4987. This area is from 0 to negative 3. If this is the area from 0 to negative 3, then this is also the area from 0 to positive 3. They are symmetrical. And again, area is always positive. Now, we do not need this area. We need these areas here. So since they are symmetrical, let me focus on one side. Half of the normal curve is 0.5. Now let us compute this area here. To solve for it, we simply have to subtract 0.4978 from 0.5. And this will give us 0.0013. So this area here is 0.0013. But we need to consider two areas. They are symmetrical, so this area is also 0.0013. So I'll simply have to multiply 0.0013 by 2. 1, 2. And this will give me 0.0026. Let us move the decimal point 2 places going to the right. 1, 2. And this will give us 0.26%. Last step, let us interpret. 0.26% of normal healthy individuals have a heart rate either below 40 or above 100 beats per minute. Another example, the average menstrual cycle is 28 days with a standard deviation of 4 days. Find the probability of women whose menstrual cycle is between 21 and 35 days. Again, our steps. Step 1, let us identify the given. So our average mu is equal to 28. Standard deviation, sigma, is equal to 4. Again, we have two x's here. X sub 1 is 21. X sub 2 is 35. Step 2, let us solve for the corresponding z values. Let's start with x sub 1. So 21 minus 28 divided by 4. This will be our z sub 1. 21 minus 28 is negative 7. Divided by 4 is negative 1.75. Now, let's have z sub 2. So, we are going to consider 35. 35 minus 28 divided by 4. 35 minus 28 is 7. Divided by 4 is positive 1.75. Next step, let us sketch our normal curve, locate these values, and label it. If this is negative 1 and this is negative 2, and then somewhere here is negative 1.75. Positive 1, positive 2, somewhere here is positive 1.75. Let us analyze the region we are going to consider. It says here between. So between negative 1.75 and positive 1.75. So this is the area that we need. Next step, let us locate in our z table. So we have negative 1.75. That would be positive 1.7. The first two digits, it's here. And then the hundredths digit is 5. On the top row, here is 5. Let us get the intersection. And the area is 0.4599. So this is the area from 0 to negative 1.75. This is also the area from 0 to positive 1.75. Now let us compute. To solve for the shaded region, we simply have to add these two areas, or we take 1 and multiply it by 2. And this will give us 0.9198. Moving to decimal places, going to the right, we have 1, 2, 91.98%. And let us interpret. 91.98% of women has a menstrual cycle between 21 to 35 days. Another example, the weight of 1,000 5-year-old children are normally distributed with a mean of 20 kilograms and a standard deviation of 1.5 kilograms. How many children have a weight which is less than 21.5 kilograms? Let us recall our steps. Step 1, let us identify the given. So our mu is 20. Our sigma is 1.5. We only have one x here, and that is 21.5. We have another given here, 1,000. This is the total number of 5-year-old children. So n is equal to 1,000. Step 2, let us solve for the corresponding z value. Let us substitute 21.5 minus 20 divided by 1.5. 21.5 minus 20 is 1.5. 1.5 divided by 1.5 is equal to 1. Next step, let us sketch the normal curve. Let us locate positive 1. It's here. Let's label it. Now, let us analyze which area are we going to consider. How many children have a weight which is less than? So if this is 1, that corresponds to 21.5, less than means going to the left. We all know that half of a bell curve is 0.5, so we simply have to look for this portion. So let us locate it in our z table. Positive 1, here is 1. This is a whole number, so the hundredths digit is 0. Get the intersection. The area is 0.3413. This area is from 0 to positive 1. Now, let us compute what is asked. We need this total area here, so we simply add 0.5 and 0.3413. And this will give us 0.8413. But we are not asked of the percentage or probability. We are asked how many children. To solve for that, we simply have to multiply the probability, which is 0.8413, by the total number of children. And this will give us 841.3. Remember, we are looking for number of children. So these are people. So 0.3 is not yet a complete person. So our answer is 841. Let us interpret. 841 children have a weight less than 21.5 kilograms. Another one. The IQ scores of 1,000 students are normally distributed with a mean of 100 and a standard deviation of 15. How many students have an IQ which is higher than 115? Again, our steps. Number 1, identify the given. Our mean is 100. Our standard deviation is 15. Our x here is 115. Again, we have here another given, 1,000, which is the total number of students. So, n is equal to 1,000. Step 2, let us solve for the corresponding z value. Our x is 115 minus mu is 100 divided by standard deviation 15. 115 minus 100 is 15 divided by 15 is equal to 1. Step 3, let us sketch our normal curve. Positive 1 is in here. Let's label it. Step 4, analyze which area we are going to consider. It says here, higher than 115. The z-score of 1 corresponds to 115. If we are looking for higher than 115, then we must shade the region on the right. Next step, let us locate this in our z table. So this is a whole number. We have here 1.0. The hundredths digit, of course, is 0. Let us get the intersection. And the area is 0.3413. But this area here is from 0 to positive 1. And we are not after this area. We are after this area. So let us compute. And to do that, we know that half of a bell curve is 0.5. To solve for this area, we simply have to subtract 0.3413 from 0.5. And this will give us 0.1587. And this is the area of the shaded region here. But we are not asked to solve for the percentage or probability. We are asked how many students. So all we have to do is to multiply this probability to the total number of students. And this will give us 158.7. Again, we are looking for number of students. So we're looking for the count of people. 0.7 is not yet a complete person. So we do not consider this even though this is higher than 0.5. So our final answer is 158 students. Let us interpret that. 158 students have an IQ higher than 115. Let us do extra challenge. Loy will take the National Achievement Test. Scores in NAT are normally distributed with a mu of 240 and a sigma of 32. What must be the score of Loy if she aims to belong in the highest 5%? So let us identify here. It's already given. Mu is equal to 240. Sigma is equal to 32. But we do not have x value nor z score. So first, let us graph this one. Since Loy aims to belong in the highest 5%, then we are going to shade the rightmost 5%. So this is the 5%. So we are looking for this value of z. Now, we all know that half of a normal curve is 50%. So this means this portion here is 50% minus 5%. That is 45% or 0.45. Now, we are going to look for this in our z table. Let's look for an area. So here, we are going to focus our eyes here. These are the areas. So 0.45. Let's look for 0.45. The closest to 0.45 is these two areas here. It is not an exact 0.45. So what we are going to do is to interpolate these values here. So let us write 0.4495, this one. The corresponding z-value of this is 1.6T4. This one, 0.04505, the corresponding value of this is 1.6T5. Now, to interpolate, we are just going to add this 2 and divide it by 2. And this will give us 0.45. This is what we are looking for. To solve for the corresponding z-value, we are going to do the same thing here. So let us add this 2 and divide it by 2. And this will give us 1.645. This means this value here is 1.645. Remember, in our previous lesson, we can convert a z-score into raw score. Our formula for that is x is equal to mu plus the z-score times the sigma. Our mu is 240, our z is 1.645, and our sigma is 32. Computing this, it will give us 292.64. Ma'am, are we going to round down or round up? Again, we are looking for a score. So if Lois' score is 292, then that will fall on this area. But if her score is 293, then it will fall in this area. So this should be rounded up, and this is equal to 293. Finally, let us interpret. Loy needs to score 293 to belong in the highest 5%. Once again, here is the summary of what we discussed. Now, it is time to check your understanding. Pause this video for more time. Let us answer. Our mean here is 87. Our standard deviation is 5. The mean is the 50th percentile. So if it is 67th, then it is somewhere here. 67th percentile, we're going to shade this area, and this area is equivalent to 0.67. Now we are going to find the corresponding z-value here. We know that half of a bell curve is equal to 0.5. So 0.67 minus 0.5 will give us 0.17. This 0.17 is this portion here from 0 up to here. This is 0.17. Let us locate this in our table. So let us look for 0.17, and it is here. So the corresponding z-value is 0.44. So this is 0.44. This is the corresponding z-value. To solve for the raw score, again, let us use our formula. Let us substitute. Our mu is 87. Our z-score is 0.44. And our sigma is equal to 5. And this will give us 89.2. This 89.2 is the average of Esmeralda. No need to round up, no need to round down, because average is usually given with decimal. So let us interpret. Esmeralda's average is 89.2. Gets? Our next lesson is random sampling.